Good day. So today we are going to learn the concept of force. So first, we are going to define the fundamentally what is force. So from our elementary, we learned that force is defined to be a what we call as push or pull movement on certain object. So say for example, we have here an object. Say it is on the floor. And we have here this object resting on the floor. And if you wanted to move the object, if you wanted to move this one, going to the right, all you have to do is to apply force, or you're going to what we call as to push this one. Push. So if you're going to push the object, then it will gain velocity and it will move towards, say, the positive direction. That is why you have their positive velocity. Or, and the other way around, let us have another scenario. The same thing, assuming that I have here an object, and then you wanted to move the object, say, on going to left direction, going to the left. Then you don't want to push the object. Rather, you're going to pull. Say you have here a cord. Then you're going to pull this one. Then the object would have to move going to negative direction. So you have here the concept of force defined to be fundamentally as the push or a pull action acted on the object. So there must be an object. So you have here this what we call as the object. Okay, so that's it. So whenever you're going to delve the concept of force, as you can see, the object will move whenever there is something or someone who allowed the object to move. If you're going to push the object, there must be someone who pushed the object. And in that case, we may include the concept of interaction. So there must be what we call as interaction in this case. So interaction. So the concept of interaction is actually important whenever we're going to deal with the laws of motion. Okay, so force is push or a pull action on the object. So for that to happen, there must be what we call interaction between the object that is being moved and of course the one that moved the object. So talking about force, there are types of forces that we have. Types of forces. Okay, so in our daily experiences, we are actually experiencing different types of forces in our daily life, in our daily routines. We are actually experiencing forces, but we just don't know about it because we don't care about it. But in physics, we must understand the type of forces we have so that whenever we come to, say, problems, we may identify these forces and it will tell us how to resolve certain problem. Okay, so the first force that we have is, say, the gravity, or I'm going to differentiate this one to give the forces according to their types. So we have this non-contact force, non-contact forces, and then we also have here the contact forces. Okay, so when we talk about contact forces, non-contact forces, I mean, it is characterized by long-range forces. Long range means say long-range interaction. But even though two objects or two interacting bodies are far away from each other, still there is a presence of what we call as force. That's basically long-range force. That is non-contact force. One of the examples of this is actually the gravity. Okay, so basically gravity is a force. Okay, so we may denote gravity as Fg, although there are different ways in how to denote gravity so that you can represent that one as a variable, not the word itself. Okay, so gravity, we may think, if we talk about gravity, we may think of two objects, and these objects are actually, say, uh, of non-negligible mass. For example, let's say we have here the sun, and we have here the earth. Let me denote earth as E. Sun actually is pulling the earth. At the same time, the earth is pulling the sun. So you have here the gravity, the force of the sun, from the sun acting on the earth. So this is the force from the sun. Then this one also is the force from the earth, of earth acting the sun. So they are actually pulling with each other. But you might be asking how it came to pass that earth does not fall towards the sun. Well, to answer that, we may go back to the concept of motion. Note that the earth is moving. Okay? So there are considerations. Why is it that the sun does not fall, the earth doesn't fall directly towards the sun? Okay? Despite the fact that they are pulling towards each other. Okay? So that's it. That's one of the example. Another example is that we have the earth and the moon. Okay? So we have here the moon. Say this is our moon. So in this case, in case of moon and earth, the moon is actually pulling the earth. At the same time, the earth is pulling the moon. One of the very concrete effects of the earth and moon interaction is that the tides that we have. Okay, the tide actually is a result of the interaction of earth and the moon. The water rises directed to the moon, as well as the tide is also an effect of the interaction of earth and the sun. Okay, that is because of gravitational force. Let me rearrange the situation. Okay, so let me have this. Let me rearrange the scenario. So I think I am doing it wrong. Okay, I'm going to place now the moon and earth in line. In this case, but before that, this case, this setup, the tide, basically, the water level, basically something like this. Something like this. Okay, see how there. But whenever the moon would have to have a great effect on the earth because it is nearer. Okay, so if you're going to to, to know the characteristics of gravity, so there must be actually this what we call as factor of distance. As the distance increases, the gravitational force, or the force of gravity, decreases. Okay. However, whenever the sun and the moon are in line, and the earth also are in line with each other, so you have here the moon now. So you have here the moon, then the level of water will be different. The tide, I mean, talking about the level of water in tide. So it would be much higher. I'm trying to exaggerate this one. It would be much higher compared to the thing that the moon, the earth, and the sun are perpendicular with each other. So the tide here would be higher, or the water level would be higher, because there is a great influence or bigger influence of moon and the sun on the tide. So you have there. So it's a force of gravity. Even though they are far with each other, still there is existing of this what we call as force. We call that one as gravity. Another thing is electromagnetic force. Electromagnetic force. So electromagnetic force. It is another type of force, which is basically long range. So I'm not going to delve deeper on this. Okay, so we're going to have now the contact forces. So the term contact, there should be what we call as surface interaction. This is a long range interaction, but in here there is contact, or the surfaces of two interacting bodies are in contact with each other. So surface is interaction. Okay, so they are actually in contact with each other. Okay, one type of the force that I can give for contact forces is, say, friction. So frictional force basically is a contact force. Let me go back to the interaction, the figure that I have shown earlier. So I have here this floor, and on the floor I'm going to place an object. Say this is the object. I'm going to rest that one on the floor. So if I'm going to push the object, I'm going to push this one. So the object will move in the direction of the force I applied, or the push I applied. It will move towards the positive x-axis. Say we are going to superimpose this one in the positive, in our Cartesian coordinate system. So it will move towards the positive x-axis. Thus, it has a positive velocity. Okay, so the movement or the motion of the object is basically a result of the applied force, or as a result of the push applied on the object. Okay, so we're going to go deeper, not necessarily on the movement of the object, but I want you to look into the interacting surfaces, the surface of the object, the surface of the object, and of course the surface of the floor. So we have here, this is the floor. Now this one here, the interacting surfaces here, that's where we can find what we call as friction. That is friction, the interaction between the surfaces of these two objects. So you have there. So the friction basically, this is always an opposite. This is always opposite to the direction of the object. If the object moves to this direction, then automatically we can say, or we can safely say, that the force of friction is going to this direction, because friction basically is a force which is always against the motion direction. It is always against the direction of the motion. So meaning, say, if you're going to move the object to the left, then the friction is going to the right. It is always opposite. Okay, notice this push. Okay, notice the push I applied on the object. Actually, when I push the object, I am actually applying what we call as force. So there's a force due to push, and we can say, or we can call it as applied force. That is applied force. That applied force can be push or a pull action acted on the object. Okay, because you can push, you can pull actually the object. And by the way, the notation for force, we can simply write the force of friction as F, or we can have this one as capital F denoting force, and then sub F which denotes friction. So we may have this one as the notation. Then next to that, let's have this what we call as compressive force, or say tensional force. Let me have first the tensional force. Okay, so tensional force, actually, again, this is still a contact force. This can be found in, say, ropes. Then what else? In cords. For example, I have here the ceiling. I have here the ceiling. Okay, this is a ceiling. Then I am trying to place here an object, hang this one. Then I have here a rope. So the object has mass m. We all know that if we are going to hang an object, the rope here will become, how do you call this one? Will become straight or being stretched. Okay, so the force that's supporting, okay, the force that supports this object not to fall down is actually a force that can be found in the cord, and we call that one as tensional force. Okay, this is tensional force. Where is my cursor? I don't know where my cursor is right now. So this is a tensional force. Okay, so you have here the rope. Let me emphasize that this one is a rope. Okay, this is a rope. So if you're going to see a rope which is stretched, then you can find there what we call a tensional force. Okay, so we are going to have the directions of these forces, because force actually is a vector quantity which requires then what we call as direction. But we're going to have that one deeper the next videos I'm going to prepare. Then the next one, let me have compressive force. compression or compressive force. Okay, so in compressive force, you can find that as an example of that. If we have here, say, a block resting on the floor. So we have here a block resting on the floor. If I'm going to push this object, say I'm going to push this object, I'm going to push this downward. The individual atoms, this object basically is being compressed. It is actually being compressed. So the material within this object will experience a force. So since it is resting on the floor, then basically according to the third law of motion, if you're going to push this one downward, this one, the floor would have to push back against on the force that you applied. I mean against on the direction. Okay, against on the direction. I mean against on the this one subject. If you're going to push downward, then the floor would have to exert force going upward. And basically, this object is being compressed. Okay, so the concept of compressive forces or compression force is very important in the analysis of, say, buildings. Okay, so the materials, the beams, the posts, or whatever, the supports, the pillars should have high resistance to what we call as compressive force, so that it won't collapse. Okay, it would be ironic if you're going to place pillars which is soft, so it will easily or eventually collapse. So you have there. So we have this 4. Okay. So going back, number 5. Going back to this illustration, okay, in illustration number 4, the force actually exerted by the floor. Notice that there is a force exerted by the floor on the object as the object is being pushed downward. There is that the force actually is what we call as the normal force. Okay, meaning to say that we have another force which is what we call as the normal. And this normal force actually is present everywhere whenever there is contact or there are contacts between two objects. So for example, you are sitting on the floor, then the floor is exerting force on you perpendicular to the floor. Actually, this is actually perpendicular force exerted. This is always perpendicular. Perpendicular with respect to the surface. Okay, so in this case, this is a floor, so the normal force exerted by the floor on the object is, of course, perpendicular. So you have here, I'm just going to exaggerate this. So I have here this one. This is the normal force. Normal force is usually denoted as N. Okay, so it is perpendicular. Notice that it is perpendicular to the surface. Okay, so That's it. I'm just going to have this 5. These are the 5 or important concepts or forces that we should understand. Okay, and we're going to use in the problems that we are going to have in the future. So, in summary, so forces can have two. We have the contact forces and non-contact forces. So basically, contact forces, these are the forces that are actually have what we call as contact or surface interaction, while non-contact forces, these are long-range interaction between objects. Okay, so so as an example of the non-contact forces, we have gravity and we have electromagnetic wave. Okay, so every day basically we are experiencing different type of forces. We are actually pulled down by the earth. So we have here gravity. We are experiencing gravitational force due to the earth. Then we are also experiencing gravitational force due to the sun. However, we are much more we are nearer to the earth. We are on the surface of the earth. That is why the force or the pull of earth is greater than the pull of the sun. So that is why the sun cannot pull us upward unless if you're going to go to space, then position yourself near the sun and you will have to be pulled by the sun towards the sun, of course. Okay, then the non-contact forces, you must try to imagine if you're going to let an apple, if you're going to hold an apple, then if you're going to release the apple will have to fall downward. Okay, it will fall downward, it will not go upwards. So as it goes downward, we're looking into what causes the apple to fall downward. You might be asking, what causes the apple to fall downward? Well, basically it is the gravitational force. Okay, so you can see there is no contact between the earth and the apple falling, yet the apple is falling towards the earth. Okay, whenever the apple have contact already with the earth, then there will be what we call as contact forces present. What are these contact forces? We have here the normal force, basically the force exerted by the surface of the earth upward. Okay, another we have here the frictional force. Frictional force basically it leads to the stoppage of the moving object. As you can see, if the apple fall downward, it will eventually stop. If it is rolling, then later on it will roll. The rolling motion will stop because of the frictional force. And if you're going to kick the apple, then you're applying force. Then that is what we call applied force. If you are going to hang the apple using a rope, then you have the tensional force. Then if you are going to press the apple, then you are applying compressive force. Okay, so that's it. Let's have another video on the other concepts that we're going to tackle regarding forces, and that will be higher relative to this, of course. Thank you.